Welcome to the debate. Today we're looking at a collision between two very different worlds. You've got the high-speed, break-things culture of Silicon Valley, and then the slow, deliberate rigor of academic pedagogy. We are analyzing AI Quests, a new literacy initiative from Google Research and the Stanford Accelerator for Learning.
And it's a collaboration that addresses a discrepancy in the data that it's actually quite alarming. We have a generation where something like 72% of students routinely use AI tools, ChatGPT, Gemini, you name it. But only 28% can actually accurately describe how a large language model even predicts text. We're looking at a user base that is highly active, functionally illiterate about the tools they're using.
And that really defines the central tension for us today. How do we close that canyon between usage and understanding? Do we build literacy by immersing students in these high-stakes, gamified narratives where they play the hero saving the world with AI? Or does true literacy require stripping away all that glossy fiction to focus on the dry, mechanical limitations of the machine?
I'm firmly on the side of what the researchers call epistemic vigilance. My argument is that in an era of deepfakes and hallucinations, the priority has to be demystification. We need to focus on data cleaning, model failure, the limits of machine reasoning. We just can't afford to let students confuse a game with reality.
And I am arguing for narrative agency. I think by placing students in the shoes of researchers solving what they call grand challenges, like flood forecasting or disease detection, we transform AI from some kind of magic trick into a tool for human empowerment. You just can't teach a student who is already tuned out. Engagement is the prerequisite for rigorous learning.
Engagement is useful, certainly, but we have to ask what exactly they're engaging with. Are they engaging with the science or with the fantasy?
Let's look at the landscape that even necessitated this project. The Stanford team, which was led by Victor Lee, they identified a massive failure in how we currently teach tech. We spent years teaching prompt engineering as if it were a stable career path, which we now know was a mistake. Or we try to teach abstract coding to 12-year-olds.
Which works for some students, the ones who are already technically inclined.
It works for a tiny minority. For the rest, coding is abstract, it's logic-based, and it's completely divorced from human context. It's boring. The AI Quests approach, and this is specifically the work by Alon Harris at Google and the Stanford team, it flips this. They aren't starting with the code, they're starting with the problem. They're offering these instructor-led gamified experiences where students act as researchers answering grand challenges.
Grand challenges is a heavy phrase for a middle school curriculum. It sounds a bit like marketing speak, doesn't it?
But it fits the scope of the material. They're building climate warning systems. They're mapping the human brain. The premise is that students need to feel the weight of the problem. If a student doesn't care about the village flooding, they are not going to care about the neural network designed to prevent it. They want to reach 2 million students by 2026. You don't get those numbers with textbooks on neural network architecture. You get them by giving students agency.
I understand the numbers game, I do, and I understand the need to scale. But I worry that agency in a video game is a counterfeit version of agency in reality. The term epistemic vigilance appears throughout the source material for a reason. It is the critical wedge here.
It's a dense academic term, though. Unpack it for the context of a middle school classroom. What does that actually look like on a Tuesday morning in 7th grade?
It means maintaining an active, skeptical monitoring of the gap between human intent and machine output. It's the opposite of immersion. Immersion asks you to suspend disbelief, get lost in the story. Epistemic vigilance asks you to stay awake and watch the machine fail. The danger we face with Gen I is the magic box myth. This idea that you put a question in the box and the truth comes out. So if this game is too polished, if the narrative is too heroic, we reinforce that magic. We teach them, look, the AI saved the village, instead of look how the AI failed to predict the flood until we fix the data.
But you're assuming the narrative precludes the technical lesson. I would argue the narrative justifies the technical lesson. Let's look at the first core point of contention, narrative immersion versus scientific accuracy. In the flood forecasting quest, They introduce a character named Luna.
The market manager.
Right. Luna manages market martyrs on the Sassa River. She isn't a scientist, she's a stakeholder. She explicitly tells the student, if this prediction is wrong, the market floods, we lose everything.
It's high drama, I'll give you that. It feels very cinematic.
It's necessary stakes. In a traditional classroom, if you mess up a dataset, you get a C-. In this quest, if you mess up the dataset, Luna loses her livelihood. That context changes the student's relationship with the data. They aren't tweaking the model to please a teacher. They're doing it to solve a human problem. That teaches the most important lesson of all. AI isn't about code. It's about its impact on human lives.
I don't deny that Luna makes the problem feel urgent. My concern is the trade-off you make when you fictionalize the science to fit that drama. Let's look at the eye disease quest. Now, this was based on real Google research regarding diabetic retinopathy. It's a serious, complex medical condition where AI is actually saving sight. But that's not what is in the game, is it?
They made an adaptation, yes.
They fabricated a disease. They created a UV exposure condition for a fictional community. Now, the material states they did this to avoid medical triggers and biological essentialism, which, I understand is a sensitivity concern. But we have to ask, does this abstraction hide the messy reality of biological data? Real medical data is ugly. It's inconsistent. It can be terrifying. By creating a safe, sanitized disease, are we teaching them how AI works in medicine, or are we teaching them how AI works in a fantasy land?
That is a cynical read on what I think is a smart pedagogical choice. Think about the cognitive load of a 12-year-old. If you introduce diabetic retinopathy, you have to explain diabetes, blood vessels, retinal imaging. You risk losing them in the biology before you even get to the computer science. By using the UV exposure metaphor, they preserve the structural truth. Data diversity changes model accuracy. The lesson is that different regions have different levels of UV exposure, and if your training data only comes from one region, your model fails in the other. That is the exact mechanism of bias in real medical AI. They preserve the logic while lowering the barrier to entry. That isn't hiding reality, that is making the concept accessible.
I suppose my fear is that we are training students to solve clean, invented problems. In the real world, you don't get to invent a UV disease to make the math easier. But I will concede that not every problem in the game is clean. In fact, this leads us to the one area where I found myself actually nodding along with the project.
The data collection phase.
The scavenger hunt. In the flood forecasting quest, the data doesn't just appear. The students have to go on a hunt for 12 different data sources, and this is the key. They have to distinguish relevant from irrelevant info.
It's a great mechanic because it creates friction.
Friction is the most important teacher here. We live in a world of ChatGPT instant gratification. You ask, it answers. This game breaks that loop. It forces the student to realize that before the AI can do anything smart, a human has to do something incredibly tedious. They have to clean the data. If they skip this boring work, they get a suboptimal model.
And I'll add a layer to that, which I found fascinating. Alon Harris noted a specific struggle they encountered during testing. They found that teenagers, this digital native generation, explicitly did not understand the abstract concept of a computer file.
This is that cloud native problem we've been hearing about from computer science professors.
Exactly. They have grown up with iPads and Chromebooks where everything is just in the cloud, files just exist. They don't move them, they don't store them locally. The concept of a discrete packet of data sitting in a folder was foreign.
Which is terrifying for the future of the workforce, frankly. If you don't understand file structures, how do you understand data architecture?
So the designers introduced physical SD cards into the game interface. To clean the data or move it, the student has to physically drag these digital SD cards around. It grounds the abstract concept of storage and transfer into a tactile action. It transforms a chore, cleaning data, into a gameplay mechanic where they have to qualify the data to proceed.
It makes the invisible visible. I support that entirely. It's a brilliant, meaningful metaphor. However, I want to push on what happens after the data is on the card. This brings us to the black box.
The training and testing phase.
This is notoriously the hardest thing to explain to a lay person, let alone a middle schooler. The difference between training a model and testing it. In the real world, this is advanced calculus.
It's loss functions, it's gradient descent.
And obviously, you can't throw calculus at a seventh grader, so they used a visualization, the low match, high match visual. Instead of seeing algorithms, the students see a visual comparison of the model's output line against the ground truth of historical data.
Ground truth being the actual historical records of what happened.
Correct. If the model's prediction line hugs the historical data line, it's a high match. If it diverges, it's a low match. It's intuitive. A 12-year-old can look at that and say, the lines don't match, the model is bad.
It is intuitive, but is it rigorous? My concern with visual matching is that it risks oversimplification. Students might think the AI is just tracing a shape. The crucial lesson, the epistemic vigilance lesson, is understanding that the AI is predicting based on patterns it found in the training data. If we just reduce it to matching lines, are we missing the why? Are we teaching them pattern recognition, or are we teaching them how a machine learns?
You have to meet them where they are. If you explain the why with math, you lose 90% of the room. But they did include a specific design choice to counter the idea that the AI sees like a human. In the vision-based quests, the image data has to be converted into numbers before the AI processes it.
That I liked. I admit that was a strong choice.
It shows that the computer doesn't see a cat or a flood. It sees a matrix of pixel values.
Exactly. That is the kind of friction I want more of. It supports the goal of removing the person hiding in the computer fallacy. If a student sees a picture, they project human understanding onto the machine. If they see a grid of numbers, they realize the computer is just doing math. That distinction is the difference between literacy and fantasy. I just wish the low match, high match visual was equally rigorous in showing why the match is low.
But the game doesn't just say wrong. It creates a feedback loop. And this is where the gaming aspect actually serves the rigor aspect. They use teachable agents.
This utilizes the protege effect.
Right. The psychological principle is that you learn better when you have to teach someone else. In the game, the student isn't just using AI. They are the mentor to a virtual AI agent. If the student does a bad job cleaning data upstream, the agent fails downstream.
This is the strongest argument for this entire initiative. It forces an understanding of garbage in, garbage out, but it goes a step further. Victor Lee made a point about self-explanation that I found critical. After cleaning the data, the student has to articulate what they did to the in-game agent.
They have to justify their choices. They have to tell the agent, I removed this data point because it was an anomaly.
That act externalizing their thinking is where the actual learning happens. It's not in the clicking, it's in the explaining. It forces them to stop and realize, wait, I made that decision. The AI didn't decide to ignore that data. I did. That is the essence of epistemic vigilance. It highlights human agency in the loop.
So, in a way, the narrative structure you were skeptical of, the idea that you are a mentor to this agent, is exactly what supports the technical lesson you want. You couldn't have that teachable agent dynamic if you didn't have the game characters.
Perhaps, or at least the characters provide a vessel for the pedagogy. But does it work? We can theorize about mechanics all day, but the Stanford team actually sent 600 volunteers into schools. They watched real kids interact with this.
And the feedback was telling. It wasn't just, this is fun. In fact, some of it was, this is hard.
Which is good. If they aren't struggling, they aren't learning.
But there was one anecdote that really stuck out to me. A teenager who was predictably cynical about playing an educational game eventually admitted her big takeaway. She said, AI is a means, not an end. It's not magic.
That is the win. I will admit that anecdote softens my stance. If a game can get a cynical teenager to admit that AI isn't magic, then it has value. My skepticism remains about whether the save the world narrative oversimplifies the complexity of solving real crises. Solving climate change isn't just about cleaning a data set, and I don't want kids thinking they can code their way out of political or social crises.
But that's why they're evolving the curriculum. They're adding the brain mapping quest in summer 2026. They're escalating the complexity. They're moving from predicting a flood, which is somewhat reactive, to accelerating discovery.
Explain the distinction there. How does the pedagogy shift?
In the brain mapping quest, they show how AI helps scientists map the connectome, the wiring of the brain. This isn't just automation, it's doing science that humans cannot do alone because of the sheer scale of it all. It frames AI as a telescope, not a replacement for the astronomer.
And that distinction, not just chatbots, is essential. We are currently in a hype cycle where everyone thinks AI equals large language model. Showing the diversity of AI applications, from vision to predictive modeling to scientific discovery, is a service to the field.
It broadens the horizon. It takes the conversation beyond how do I cheat on my essay to how do I cure a disease.
Which is where the conversation needs to be. But I must reiterate, the tool is only as good as the critical thinking of the user. We can give them the telescope, but we have to teach them how to look through it without hallucinating what they want to see.
So, where do we land? I look at this initiative and I see a triumphant example of how we can take dry, complex material and make it accessible. I see Luna, the market manager, giving a human face to data science. And I see students engaging with material they would otherwise just ignore.
And I look at it and see a useful, albeit imperfect tool. I see the value in the scavenger hunt and the teachable agent because they introduce friction. But I maintain that the success of this program won't be measured by how many kids play the game or even by the 2 million student target. It will be measured by how many kids walk away doubting the machine. If they leave the game feeling powerful, that's fine. But if they leave the game feeling skeptical, that's better.
I think we can agree that the ultimate lesson isn't about coding. It's about realizing that the digital universe is counting on human decisions to make AI work responsibly.
Indeed. Whether you learn that through a quest or a textbook, that is the lesson that matters.
That's all the time we have for today. Thank you for joining us on The Debate.
Stay vigilant.